once again, representing to online. As usual, we are here to simplify what you people take to be difficult, to simplify concepts that you people fear to attempt. Like we discovered previously, that most of the learners, they have covered most of the information, but the problem is with how to respond to different scenarios. So this target, this week's target is to soften, to simplify some of the items, possible items in different subjects. For today, I'm simply here to soften chemistry. Again, I'm here with some scenarios. I want us to go through, me and you. By the end of this video, we must make sure that these kinds of items of this category we are going to discuss about are now simpler, a level that you can pass. So that's why I welcome questions. Type your questions as early as possible, so that when I break for replying such questions, I have the question. They are already in the comment section. So, like I've said, I'm representing to online. Like we always say, you can only reach us via 0703 278 231. That is our WhatsApp number, the administrator's WhatsApp number. When you reach us via that, we can automatically add you to our group. We have our question written, handwritten, because we like developing our own questions, not using the usual questions people always set. That's why we always develop our own. So we have a question there. You can screenshot the question, or wait until when the video ends, the lesson ends, and you review it and get the item. But it goes. During an archaeological study on a rocket tool of an isotope, this one, hope you see that isotope that was discovered, the researcher found out that the tool had decayed with emission of 4 particles that were seen to be deflected towards a negative plate in an electric field to form the present isotope, this one. Let me think you can see it. Members, this is chemistry, and it is a scenario in chemistry I want us to go through. The head of the research team instructed the team secretary to write a report. However, the secretary did not have any idea about the requirements of the report according to the head of the team requirements. So as a chemistry learner, write the following as required in the report. In the report, they want a learner to write or to state the particles that were emitted by the tool during the decay process. Part B, they want us to write an equation for the decay of the rocket tool with determining the values of A and B in the isotope. Part C, they want us to mention, they wanted the secretary to include any other characteristics of the particles emitted. And finally, part D, Roman 1, we state some uses of such isotopes in the kind of that of X. And finally, the challenges associated with repeated exposure to such emitted particles. So you can screenshot the scenario. From there, you can screenshot the scenario. You'll maybe go through it later. and then the T6. Yeah. To save time, the scenario is as that. So they are saying that in a certain research, the archaeologists discovered a certain rock tool that was used long ago. This rocket tool was made from an isotope, unknown isotope of a certain element, whose atomic number is not known, and the mass number. So yeah, this is A, this is B from the scenario. So the isotope was of a certain element X, whose atomic mass was not known, and the atomic number 2. But this element had gone a decay. We all know the meaning of the word decay, which is the spontaneous disintegration of a certain isotope with emission of certain particles. But this time the particles that were emitted were 4 in number, but these particles were deflected. If these are the particles from this rocket tool, this is the rocket tool X. They were found to be deflected towards the negative plate in an electric field. An electric field is always created between two charged terminals. And in the charges, we know them, the negative and the positive terminals. So the fields between two charged particles, two charged plates are the ones we call electric fields. So in their discovery, the particles emitted, irrespective of this number, were deflected towards the negative plate. Deflecting these particles towards the negative plate indicates something. It indicates that these particles were positively charged. It indicates the 4 particles that were emitted were positively charged. And if you remember very well, we had 2 categories of radiations. We had alpha particles, beta particles, and we also had gamma radiations. When we go to their properties, we found that the alpha particles were positively charged, the beta were negatively charged, and the gamma carried no charge. They were neutral. So since these particles that were emitted were deflected towards the negative plate of the electric field, of the electric plate, it indicates that the particles were positively charged. And that makes part A a response to B, alpha particles. Reason, it's because they are deflected towards the negative plate, implying that they were positively what? Charged. You remember, like charges repel, and like charges what? Attract. To go on with part B, sorry for that. To go on with part B, they are telling us to write the equation for the decay of the rocket tool. This was the rocket tool, determining the values of A and B. That means primarily we shall write this tool or this rocket tool with A up, B down will undergo decay with emission of alpha particles, because they said they were alpha particles from the description in the scenario. They said to give this isotope Y, with mass number 203 and atomic number 96. So if it underwent radioactive decay with emission of alpha particles, we said alpha particles are fast moving helium atoms. And they have told us that it decayed with emission of 4 helium particles, alpha particles. And remember, a helium nucleus has 2 neutrons, 2 protons, meaning that it has 4, mass number 4, and atomic number what? 2. So it underwent decay to form this isotope. So they want us to write an equation with the values of B and A specified. This means we shall go into a calculation. So to get A, it will be equivalent to this one, 203, plus this sign here, which is a plus sign, with a 4 in front multiplied with a 4. So to get this value here, the mass number of the mother, remember this calculation of the mother isotope or nucleus is always, the mass number of the daughter nucleus is always the mass number of the mother nucleus minus the number of particles emitted. So, minus the 4, which is the mass number of the alpha particle emitted. But this time, the mass number of the alpha particle was multiplied by a 4 because of the number of particles emitted. So we shall have this in our calculation to get the value of A. So this will be A equivalent to 203 plus 16, such that our A is 219. So the mother nucleus had mass number, the mother atom had mass number 219 from that calculation. So the same applies to B. To get B, it will be the mass of the daughter nucleus, the atomic number of the daughter nucleus, plus the atomic number of the alpha particle times the number of particles emitted, which is 4. So this means B alone will be a 96 plus 8 equivalent to such that our B is 104. So to rewrite the equation, our equation will be with the values of A and X known. Our equation will be, we have 219 up and 104 down, X, giving us 203 up, 96, an isotope of this one after emitting 4 alpha particles. So that was part B, with the values of A and B known and an equation for the decay process of X, of the rocket tool X, as required by the head of the research team. I'm coming for your questions and supplements, and I think we are moving and we are still on track. We know the reason why we went with alpha particles, not beta, not gamma radiations. To go on, part C, they are telling us to give any other characteristics of the particles emitted. Apart from being positively charged, we can talk of other characteristics of alpha particles. Other characteristics of alpha particles, they are positively charged. They mentioned that. They also mentioned that can be deflected by magnetic fields, because they mentioned it that it was deflected towards the negative plate in an electric field. So which other properties of alpha particles can we go with the members active on the live? Give us some other characteristics of alpha particles. Other characteristics of alpha particles, please. They are the ones I want to see here. I don't want to be a dictator. Members, as you write your comments, I welcome Jemima, who's with us. Nachibuka Mary, my first time to hear about her. She's with us. Banex Bongani is with us. Agaba Nicholas is with us. Joshua Joel is with us. Nakawich Fiona is with us. Kabonesa Rest is with us. And then Timothy is also with us. So you're most welcome for those with us. As I also wait for responses, I don't see. So one of the properties of alpha particles is that they move at a speed that is much less than that of light. Thank you, Fiona. Give us more, give us more, give us more. Give us more. That was from Nakauch Fiona. They have a very short range in air. Have a very short range in air. All of these are characteristics of alpha particles. Have the lowest penetration power. That can even be stopped by a thick piece of paper. Characteristics of alpha particles, we cannot mention them all. There are very many. They have the greatest ionizing energy, that is still from Fiona. It is Timothy. Timothy, greatest ionizing power, yes, great. Have the greatest ionizing power. So there are very many properties of alpha particles. We cannot finish them. And I'm very sure we all know why we went with alpha particles. The reason was given in the scenario that these particles were seen to be deflected towards the negative plate, implying that they were positively charged. That's why we went with alpha particles. So we cannot mention all. I think those are enough. Part D, they are telling us to give some uses of such isotopes that are of that kind as X. Uses of radioactive isotopes. What are some of the uses of radioactive isotopes? Remember we said that we don't cram, we just understand. And we remember some of these uses of radioactive isotopes. We said, why are we calling them radioactive isotopes? We said because they can they can undergo decay or radioactivity with emission of particles. So, some of the uses of radioactive isotopes. We remember them. We remember those uses of such isotopes. We talked of, so we say that they are used to determine or to detect presence of impurities in water, air, and food. And the kinds of impurities they detect, they are those ones that undergo decomposition, that undergo decay. These kinds of isotopes are used to treat cancer, such as the bone and the prostate cancer. We remember them. We cannot finish them. There are many. So we are looking at the various ideas of items they may set. They are used to trace for radioactive additives in food, air, and water. That is very nice from Fiona. They are used in carbon dating to determine age of remains. There are very many uses. And I think for those who follow our lessons always, when they get to their respective schools, they will find this topic the simplest. They will find the simplest topic because we've not only taught it, we have only went through some items. And the only part we are remaining with in this part, apart from nuclear fission and fusion, we have half-life. A very simple concept of these nuclear processes. We shall go through it. So, and the last part, they are telling us to give the challenges associated with repeated exposure to such particles emitted. What are some of the likely challenges one is to face when this kind of a person is repeatedly exposed to these alpha particles? Can I have the responses from you? Yes. So this is part B. Challenges associated so that associated with repeated exposure. Alpha radiations. Members, don't write these headings because we are not making notes. Maybe you may write an introducing statement. not underlining, not making capital letters. You may write just an introducing statement, not underlining it. So one of the challenges someone has mentioned here, there is genetic mutation. What brings about genetic mutation? That is an effect. What brings about genetic mutation? Please come up. Come and tell me. What brings up genetic mutations? Fiona, that was a point from you. Not just saying, genetic mutations. What brings about it? Dig the point from the grassroots. Don't cut from the stem. Dig it from the grassroots. I want to see, Fiona, what brings about genetic mutation? So we said that that point should have been phrased like these particles alter the genetic makeup of the DNA molecules. We shall find, for those who will go for biology beyond this level, you will find that if this is a DNA strand, DNA strands, they have what we call nitrogen bases that are coded on each of the strands, where we shall see they will be abbreviated as adenine, thymine, guanine, uracil. They will be abbreviated as those terms. We shall find that if we have adenine this side, we shall have thymine the other side. And each of the DNA strand or chromosome strands coding for a certain information has a certain information of these amines, these nitrogen bases. Any change in these nitrogen bases, any alternation as a result of these particles, we call it genetic change in the genetic makeup. And this one always called for mutations leading to gene mutations and hence variations and evolutions. So we said we always give the challenge, which is altering the genetic makeup, the effect of the challenge, which is mutation, and the overall impact. You also give the mitigation. How can we mitigate this? How can these people avoid getting exposed to such radiations? You go on and give a mitigation. This can be mitigated by wearing protective gears such as lead coats. Coats made out of lead. Some will put on aluminum foils. Why? Because these alpha particles cannot go through them to get to direct contacts with the body. We know the other things. Once body cells are exposed to these radiations, they always affect cell activities or cellular activities. Remember, there are these genetic materials that control cellular activities. And when they are affected, the cell activities too will also be affected, either lowering or stopping metabolism, leading to cancers or cell death, leading to failure, general failure of the entire organ or tissue, and hence death of the organism. In most cases, when some of the cellular activities are slowed down, they always lead to reactions that include irritations of the tissues where the cells are found and many others. We can talk of more and more of these effects. But remember, we said you give the challenge, the effect of the challenge, the impact of the challenge, and the mitigation. Someone asked me what is the meaning of the word mitigation. The word mitigation means a solution to a certain problem. This word stands for solutions to any stated problem, is what we call mitigation. So as you give your response, consider a challenge. You state the effect of the challenge and the overall impact. So you can also go on and include cancers as the impact altering the genetic makeup. And I think you can contribute to more challenges. Timothy is also giving another challenge that the helium produced react with those biological substances. Timothy, which biological substances? You tell me which biological substances. Skin irritations from Fiona. Yes, cancers from Fiona. Fiona, we've said, and whoever, and all of you who are like Fiona, please build the point from the start, from the grassroots. Build it from the grassroots until when you get to that mutations and cancers. So yes, Fiona has also said. Tissue deformation, tissue stroke organ deformation. This can also be an impact of genetic change in the genetic makeup. So that can also be another impact. So with that, if there is no any other question, I think we can call it a lesson and meet in the next. Thank you.